Welcome to solverfy.
Right, for each isomer, we need to determine the longest carbon chain and then also determine where, so cis or trans, the biggest functional groups are from that chain. So for the first one, we do have a 3-carbon chain, right, with the double bond being on carbon number 1, which is also where the bromine is. So we're numbering from right to left here. And since we have that methyl group, the CH3, and the bromine on the same side of the compound, we can call that a cis isomer, right? So it's a cis 1-bromo, 1-propene for the 3-carbon chain with the double bond. Right, for the next one, we actually have a 7-carbon chain when you look at the longest possible option, right? So for that 7-carbon chain, right, that is essentially the kind of the bottom part of that compound, which means the CH3 and the CH2, CH3 are on the same side. So that's another cis isomer. Right, so we have a cis isomer there. Now, when we look at this number-wise, right, we have to consider that double bond being our priority for numbering. So that means our double bond will be on carbon 3, right? If we count left to right from the starting kind of with that bottom, so CH3, CH2, then we hit that double bond. So it's going to be a heptene, so 3-heptene. From there, when we number it, we have an ethyl and a methyl, right? So ethyl comes first alphabetically. So ethyl is on the 4th carbon. Methyl is on the 3rd carbon. Those are the cis pieces of this compound. And then the double bond is 3, so it's a heptene. Finally, we have a 5-carbon chain here. So we have some iodines attached. This is kind of a weird looking chain, but we have 1, 2, 3, 4, 5, and the double bond, remember, takes priority. So we're going to number right to left here. So the first carbon has the double bond and one of the iodines. And then on the other side, okay, we have another substituent, which makes it the other iodine, which is makes it a trans isomer. Okay, with our 5-carbon chain being our longest chain. So this one is going to be a trans isomer. So our iodines are on carbon 1 and 4, and that'll be diiodo, which is a little weird, but that's the iodine. 2-propyl, because we have that 3-carbon chain. 1-pentene. All right, so the trans, okay, is our iodines. Those are opposite from each other. And the numbering is based on the location of the double bond.